Hi, welcome back to Data Science. This is Vivian here. Today we will go over Pandas, another library that is available with Python. In the previous class, we saw a library called as NumPy. In this one, we're going to go another popular one, which is Pandas. In the previous one, we saw NumPy was used for numerical operations. Pandas, which is short for panel datas, is used for data manipulation and data analysis. It provides single and multidimensional data structures. In NumPy, so you got data arrays. In this, you get a data structures, and those data structures you can manipulate. It's huge amounts of data that you can manipulate without writing too much code. That's what Pandas is used for. It gives you two different. You can start with single dimensional data structures, which are also called series object, and they are key value or kind of labeled arrays where you have indexes like 0, 1, 2, 3, which we have in typical arrays. But also you can, since the reason it's called labeled is those indexes you can change it to whatever you want. Similarly, there's multidimensional data structures which are called as data frames. They are in type of you can think of it as CSV or a table kind of format where you have items and each one of them have labels on the top and it has bunch of data sets inside there. So that's what we'll be working with. We'll start with Pandas. Let's start a Jupyter notebook, Python 3, and I'm going to call it Python Pandas. Now, as we imported NumPy, similarly, we can import Pandas and give an alias as PD, which we'll be using it going forward. Now, if I want to create a data set or data structure, single dimensional, I can use series, and inside this I can give, this is as simple as it can get, can give a list of items 1 2 3 4 5. If I look at A, if you see, these are the values and these are the indexes 0 1 2 3 4. It looks like an array, but it's not. It's a data structure which is of the type called a series. I can look at the type, and you see it says Pandas core series object. That's what it is. Now, if I want to customize these keys, I can say let's create another one, pd.series, and inside this again I'm going to do the same thing, 1 2 3 4 5, similar, but I want to give indexes to this. So you can just say index. That's how you give indexes, and you can give an array. Let's say I want to call it A, B, C, D, and E. Now in this case, if I run B, you'll see instead of having 0 1 2 3 4, which is the default behavior of a series, it will use your indexes and assign these values to those indexes. Now it looks like key value pair. So is there a way we can set it as key value? Yes, there is. So what we can do is, just to make it easier, you can say series and give a dictionary. I can say A is 1. I'm just going to give 3. B is 2 and C is 3. So just to keep it simple, I'm just giving C 3, and you see A, B, C, 3 items. Now what if I want to organize it in a different order? You can do that. You can just say, let's take the same object and say I want to use this, but I want to change the index or the order in which they appear to be, like C comes first, then comes A, then comes D. Now I'll say, where is D? So let's say if I just say D comes after that and B comes after that, what it does is it will create a new element or new item with index D and add not a number into it. So that's what it will do. It will automatically create one for you and add it after the at the particular point which you have assigned it to be. Now, how do I get a particular value from the series object? I think you have guessed it by now. If I say, let's say C of I'm going to say C of 2, and it'll say not a number because that index doesn't work. So you can say C of A, and that will give 1.0 because that's what exists. Now if I go to, let's say, my old data set, which is A, I can say A of 2, that will work, that will give me 3. Or I can say I want all the items until 2. So I'll say, okay, 0 1 and 1 2. So you can say I want all the items minus 2 So that means from behind, take the 4 or 4 5, and that's what you get, 4 5 until the end of it. So -2, -1, and 0 you don't want because it's in the start of the array of the listing. So that's how you can get items from a series object. You can also do arithmetic operations. Let's say let's print a again. This is a. Now if I say a plus 5, what it will do is it will take each and every element inside the series and add 5 to it. I can do subtract, I can do, as you probably have guessed by now, multiplication, or you can do division. So all these options are available inside the series element. Now that's how we create a single dimensional. But what about multi-dimensional that I mentioned? Multi-dimensional or data frames, they contain both rows and columns, just like a table listing. So how does it look like? Let's go ahead and create one. I can say pd dot data frame. I want to create a data frame, and I want to display inside it something called as day. First column is day, and inside that I want Monday, Tuesday, Wednesday, Thursday, and Friday. So for now I'll just say working days, and inside these working days, how many hours am I working? So I can just say hours. I can say I work 8 hours on Monday, 4 hours on Tuesday, Wednesday, Thursday, Friday. Now when I display this D, you'll see it displays in a table format. So this is how a data frame looks like. It kind of creates a table structure for you, and you can use it. You can always import another data set. That is another option. So if I want to import a particular data set, let's say for example I have this Excel which gives me the flights on a particular year, month, day of the week, departure time, CRS, arrival time, CRS arrival time, flight number. So it has all these different objects. Now I don't want to, how many items does it have? It has 100,000 items inside it. Now I don't want to add one at a time in here. What I've done is I've saved that file inside my Jupyter folder, and it's called flights.csv. So inside my Jupyter notebook, I can just say pd.read csv. That's a built-in function available with the Pandas. I can just say flights.csv. So it will load that file. I want to load it and add it to my variable flights. So if I run flights now, you'll see it will give me all the items, 100,000 rows, 17 different columns that are available, everything displayed here. It doesn't display everything, of course, because it will show ... because I have way too many items. Now what if I want to see, now there are some built-in functions that we commonly use, such as head, shape, tail, and describe. What are these? What head does is, flights.head, it will pick up the top 5 items from a particular data set. So if you see, it got me 5 items and displayed me here. Same thing, you probably have guessed, what does tail do? It will pick the last 5 items from the data set. What does shape do? Flights.shape. You have used shape before, so you probably guessed by now. Oh, it doesn't, it's not a function. If I run this, it gives me 100,000 by 17. Where have you seen this before? Right here. So shape is nothing but number of rows and columns. That's what it displays. And then there's another thing which is very important, called describe function. What does that do? If you look at it, it went through each and every column, and it said count number of items that each one of them has. So there's some of them which don't have 100,000, which means that there's data not available. Then there's mean. It gives you mean for all the years, months, since it's all for 2008. Saying mean is 2008. Standard deviation, since it's not moving too much from 2008, it's saying 2008, but others have standard deviation. Minimum 25% of the data set, 50%, 75%, max is this. These are different elements that are how many percentage are close to a particular range. So these are the different items that you get when you say describe. So that's all available to you with built-in functions. There are some other functions, something called as lock and iLock. Now what does lock and iLock do? What they do is you can get a few particular selections. For example, in this I can say flights dot lock. I want the row 0 to whatever row that I have, and I want selective columns. For example, I want arrival time and I want, let's say, air time. Just display these. I'm gonna print this out, and here I have a, okay, let's try that again. So if you see here, it will pick and choose. With lock you can say that I want only 10 rows and these columns. So that's what lock is used for. You can actually selective pick what you're looking for. What does iLock do? So I'm going to copy this. So there's another one called as iLock. Inside iLock you don't have to give these parameters. I can say I want 0 to 10 and I want 2 to 5. What it does is it will pick the second. So instead of giving the names of the rows, you can just say I want the second, third and fourth column. So it just picks up 0, 1, 2, second, third and fourth column and displays it to me. So if you don't want to give it by name, you can also say row number and column number. So that's what iLock does. There's another functionality. I can say I want to drop some of the items. For example, I can say from flights I want to drop something that, let's say, a few rows. I want to drop 1, 2 and 3, and since it's from rows, I can say axis. I have to say axis equal to 0. What this will do is this will drop first, second and third. Let's add it to, let's say, flights drop variable. Now if I print this, you'll see that 0 and 4, where did 1, 2, 3 go? So it created a new variable and dropped some of the items that we don't want. So you can actually drop items from a particular data set and then just use that, assign it to us another variable and use that for that. Similarly, if I want to drop let's say without, where's my data set here, I don't want to display, in this case, let's say departure delay. So I want to drop departure delay. I can say column equal to flights dot drop. In this I will say the thing that I want to drop is departure delay in my axis of 1. Run this. Now let's print this out. You'll see there is no departure delay in this particular table. So I've removed. So drop is used for removing columns and rows. You can pick which axis or which is rows or columns you want to do it from and assign what you want. Similarly, you can give multiple one. If you give it in an array, you can add multiple columns inside it. Next one is, how do I calculate, like we've seen by using describe, you can calculate the mean, median, everything. You can do that by just saying, oops, flights dot mean, run it, and it will say for year this is the mean, this is for month, so it will give you means for all the different columns that you have. Similarly, if you want median, you can just say that and it will give you medians for all the different columns that exist. I can also get minimum value in a particular place. Here since 2000 is common month, so it'll give me minimum values. Similarly, you probably have guessed it can, there's also function for maximum in a particular column and it'll give you maximum in a particular column. So min and max functions can be used for that. What if I want to define a function to do a particular operation on my data set? For example, I want to take my, let's go display flights again, don't want to scroll up. Inside my flights, I want to, let's say there's a lot of work going on at the airport and the taxi in and taxi out time is increasing because of a particular condition. So what I want to do is I want to define a function which adds, let's say 10 minutes to the existing taxi in taxi out. So I take a variable s and I say return s plus 10. So this is my function that I've created. Now I want to apply this to my data set. The way you can do this is you can say flights, and then I want to add it to taxi in, and these two columns, what I want to do is I want to apply, that's where we use apply, a function add 10 and run it. So if you see here, it will, I had 10, 4, 5, 3, 3, it added 10 more minutes, 14, 15, 13, 13, 13. So it adds 10 more minutes to each and every column that I have. So this way you can write a different function to kind of do data manipulation inside your data set. There's two more that we're gonna go over. The first one is called as value counts, which is counting all the different values inside a particular item. For example, how many 4s appear in taxi in, how many 5s appear in taxi in, taxi out. So how do I do value counts? For that I can say flights, I want to, let's say, count how many different types of values are there for taxi in. I can say value underscore counts. So when I run this, what it will do is it will look at, okay, 4, how many times does it appear? It appears 25,857 times. How many times 3 appears? 22,447. And it will order them by the time and how many times it appears over here. So there are 64 minutes taxi in delays, which is what happened one time, 70 one time, 51 one. There was one time taxi in took 213 minutes. Maybe there was power outage, maybe there was lightning, and then people were actually sitting inside. So these are different values that you can get from using value count. See what all different types of values exist inside and how many times they exist inside your data set. Similarly, there's something called as sort by. For example, I want to sort. Now if you see, these are not sorted in a particular order. They have 3, 4 after that, 6. What if I want to sort based on, let's say, airtime? How much time does the plane spend in air? So I can do flights dot sort underscore values, sort all the values by which field, can say airtime. So this will take my data set. Now if you see, 78,681 came to the top. Why? Because that one has probably the least number of airtime, which is 12 minutes. I don't know where that flight is flying, but there was maybe it just turned around and came back to the same airport. So 22 minutes, 23 minutes. So there are different flights, and at the end there's not a number where value is not available. It will do based on that. I can also do based on something else. If you see 17, 19, 19, 20 up to 370. So you can do sorting your data set based using sort values function. So these are some of the common functions, and later on after matplotlib, when we do real projects, we'll probably be using most of these